Hey guys, so today we are going to discuss about the question called as sum of nodes with even valued grandparent. So this is a medium level question, this is a tree question, so this is not that hard. So first of all, after reading the title of the question, so first things first, like who is a grandparent? Let's know that. So first, in our case, a grandparent is someone, for example, let's say our parents' parent is a grandparent. For example, let's say this is us. It's very weird to explain who is grandparent, but that's okay. So this is our parent and this is our parents' parent. So this is child and this is child's parent. So this will be our grandparent because our parents' parent would be our grandparent. So this is our case. So even in a tree case, it's the same. For example, let's say we have something like 1, we have 2, we have 3. So this is a tree, right? So for example, let's say this is a node. So this node's parent would be this node, this node's parent would be this node. So as the 1's parent is 2 and 2's parent is 1, so 1's grandparent would be 3. Did you get it? So this is what a grandparent is. So for example, let's take this tree. So let's take a tree. We have this tree and let's analyze who is a grandparent here. So let's starting with the 6. Who is the parent of 6? None, right? Because 6 doesn't have any parent. So let's leave that. So coming to 7. Who is the parent of 6? 7. Of course it is the top one, which is 6. Who is the grandparent of 7? None, right? Because 7 has a parent but 6 doesn't have a parent, right? So if 6 has a parent, then that parent will become grandparent to the 7. So as 6 doesn't have any parent, that actually means 7 doesn't have a grandparent. So now coming to 2. Now who is the parent of 2? Of course 7. Who is the parent of 7? It is 6, right? So if 7 is a parent of 2, then 6 is a parent of 7. That actually means 6 is a grandparent of 2, right? So 2 has a grandparent. So this is how we find a grandparent. So now what the question is actually asking. So what they're trying to say is they'll be giving a root of a binary tree, return the sum of the values of nodes with an even valued grandparent. So what they're trying to say is you have to return the sum of nodes where its grandparent should be even. You know how to find a grandparent, right? So you have to verify if that grandparent value is even or not. If it is even, then we have to add the sum, the node's value to the sum. For example, let's take this. We have found out 6 is a grandparent of 2, right? So let's take 2. Now as we know 6 is a grandparent of 2, now let's check 6 is even or not. Of course 6 is even, right? So if it is even, we can add the answer sum as 2. I mean, we can add to the sum because we have to find the sum of the nodes with even valued grandparent. So now let's come to the next node, which is 9. So 9 has a grandparent, which is 7, right? So this is the grandparent of 9. So now let's check whether 7 is an even or not, because 7 is a grandparent of 9. 7 is not even, so we can neglect that because it is not, the grandparent is not even. Similarly, 7 has a grandparent, which is 6. So now check 6 is even or not. Of course it is even. So now we can add 7 to our sum. So now again add 7 to our sum. So now again come to the next one, which is 1. So now see whether this 1 has a grandparent or not. It has a grandparent, right? So now which is 7. So 7 doesn't have a grandparent. I mean 7 is not even. So now we can neglect this one. So similarly for 4, the 4th grandparent is this 7, but 7 is not even, so we can neglect this 4 as well. Similarly, coming to this 8, as it doesn't have any grandparent because there is no grandparent for 8. It has a parent but no grandparent. We can neglect 8. Coming to 1 has a grandparent because 1's parent is 8, 8's parent is 6, which actually means 1's grandparent is 6, right? So now check whether 6 is even or not. Of course it is 6, right? So now add the current child's value to the sum. So now again coming to 3. uh 3 has a grandparent, so 3's grandparent is 6, right? So now if it is value, if 6 is even, right? So add the current value to the sum. So again, coming to 5 has a grandparent which is 8, so 8 is even again. So now add the 5 to the sum, which would be this. So the total would be 18, right? So 7 plus 2 9, 9 plus 1 10, 10 plus 13, 13 plus 5 18. So the answer for this tree would be 18, which is the sum of nodes with even value grandparent. This is how, this is the normal approach. Like, this is the question actually requires this for to get the solution. So this is the answer for this tree. So let's try, like, how do we programmatically solve this? Like how do we programmatically solve using recursion like that? Let's take another example. So let's take the previous example only. Let's take with the previous tree only. So let's find technically how do we get the sum of nodes with even value grandparent. So what I'll be doing is I'll be using 3 pointers. So let's say one pointer will be pointing to the current node. Let's say this is current. We have another pointer which is called as parent. We have another pointer which is called as grandparent. Let's say we have 3 pointers. So what we are trying to do is, initially generally a question will be giving us a root of the node, right? So let's assume we got the same. They will be giving you the root of the node. So now starting with this, we'll be seeing whether 6 has a parent or not. It doesn't have a parent, right? So we can move forward. I'll be doing pre-order here. So now again, what we'll be doing is, initially 6, the current one is 6, right? Parent is null and grandparent is also null because 6 doesn't have a parent and a grandparent as well. So now when we move to the left side to 7, the current one will become a parent and the parent will become a grandparent, right? So what I'll be doing is I'll be exchanging the values. So now our new values would be, current would become 7 and parent would become 6, and grandparent is anyhow null because previously parent is also null. So now what we'll be seeing, if whether grandparent is null or not. It is null, right? So that actually means there is no grandparent for 7, so we can move forward again. So now I'll be moving to 2, right? So now what I'll be doing is, this current will become parent and this parent will become grandparent, right? I'll be changing the values. So now current will become 2, parent will become 7, this grandparent will become 6. So now let's check 2 is null or not. 2's grandparent is null or not. So 2's grandparent is not null, which actually means there is grandparent for 2, which is 6. So 6, let's check 6 is even or not. 6 is even, so that actually means we have to add this 2 for the sum. So let's keep track of the sum as well. So now the sum would be 2. So now again let's go to 9. So now let's erase this. So let's take this out as well. So now current would be 9 and parent would be 2 and grandparent would be 7. So now let's check the grandparent is null or not. It is not null, which actually means there is a grandparent for 9. So now let's check whether the grandparent is even or not. If it is even, then we have to add 9 to the sum. So as 7 is not even, we can neglect 9. So now moving back again, like a pre-order traversal. So 2 doesn't have any right? We again go back to 7, this 7. So now again we come to this 7. So now what we'll be doing is, in this position the parent of 7 is 6, right? So now, which actually means current would be 7, parent of this current 7 would be this 7, and the parent of that 7 would be 6, which actually means grandparent of 7 is 6, right? So now let's check whether 6 is even or not. It is even, right? So now we have to add 7 to the answer. Similarly, we are going downwards to 1, which actually means the parent would become the 7, current would become 1, we are just exchanging like this, and parent would become 7 and grandparent would become 7, right? So now let's check 7 is even or not. It is not even, so we can neglect this one. So coming back from 1 and going to 4. So now current would become, let's erase this again. So current would become 4, parent would become 7, and grandparent would become 7. So as the grandparent is not even, so we can neglect this 4 as well. So now again we are done with all of this left subtree, right? So now again coming to this position. So now what we'll be having is the current would be the 8. Current would be 8, right? Would be 8, and parent would be 6, and grandparent would be null. So now as the grandparent is null, we cannot, we don't have to check, because anyhow it doesn't have any grandparent. So now I can go to 1. So now I'll be exchanging these positions. So current will become the new node, which is 1. So the parent will become the previous current, the grandparent will become the previous parent. So now current would be 1, parent would be 8, and grandparent would be 6. So now let's check grandparent is null or not. It is not null, right? So we can check 6 is even or not. 6 is definitely even. So let's add this 1 to the answer. So plus 1. So now similarly, it doesn't have any left node, it doesn't have any right node. Let's go back. So now let's go to the right subtree. So now the current would be 3, and parent would be 8, and grandparent would be 6. Grandparent is 6, which actually means it is even. So let's add this 3 to the answer. So plus 3. Again going downwards. So now current would become 5, and parent would become the previous current, and grandparent would become previous parent. So now current would be 5, parent would be 3, grandparent would become 8. So now as the grandparent is even, we can add this 5 to the answer, which is this 5. So plus 5. So now we are pretty much done with the entire tree, right? So we come back again recursively to the root node. So now the sum of the ones which you have kept track of would be our answer. So 2 plus 7 plus 1 plus 3 plus 5. So this would be 18. So this is how we find, like, recursively how to get the sum of nodes with even value grandparent. So now let's see the code. How do we implement this? So now we are having a method called as sum even grandparent. So they'll be passing us a parameter which contains a root, which is the root of the tree, right? So let's use a method, a helper method. So because we cannot use this method only because it has only a single parameter, so we cannot change the signature of it. So let's use some other helper method. Let's say it's a void DFS, and let's say we have parameters called current, which will be pointing to the current node, and there is something called as parent, which will be pointing to the parent node, and there is something called as grandparent, which will be pointing to the grandparent of the current node. So initially what I'll be doing is I'll be calling this method. So the current node will be the root itself, right? So it will be the root. So root doesn't have any parent, so the parent will be passing the null. So even for the grandparent will be passing the null. So now I'll be using a variable called as sum to add the sum, so that I can return this sum after completion of DFS function, so which would be returning sum. So now first things first, I'll be checking if current is equal to null or not. If it is null, I'll just return. And now which is, we have to check whether the current node has a grandparent or not. So initially the current node would be 6, right? So for this case I have to check whether it has a grandparent or not. So how do we check whether it has a grandparent or not? By using this variable. So if it is null, that actually means it doesn't have any grandparent. If it is not null, it has a grandparent. So if grandparent is equal to null, is not equal to null, and grandparent percent dot value percentile 2 is equal to 0. So what it's trying to do is it is checking it if grandparent is not equal to null, and if grandparent value is divisible by 2, which actually means if it is even. If it is even, then I'll be adding the current node's value to the sum. So plus sum plus current dot value. So if this doesn't satisfy, then I'll be not adding the current value to the sum. So after adding, I'll be going towards the left, right? So now this is the main thing. So in this case, what will be happening is the next node will be the current node, which will be the left node, current dot left. So the current node for the left node, the parent for the left node will be the current node, and the grandparent for the left node would be the current parent's node, current node's parent. Did you get it? Like how we have done before. So now this would be grandparent. So even for the right, so this would be current dot right. So the parent for the right node would be the current node, and grandparent would be this would be the parent node. Sorry, this would be the parent node, and the grandparent will be current node's parent. So yeah, this will be the parent node. So this is pretty much the recursive solution. So it will just perform DFS for each and every node, and then perform that validations using this if loop, if condition. So let's try to compile this. Let's hope for no compilation errors. Yeah, see, we have got 18 as answer, like we have got in the previous example during explanation. So let's use extra test case as well. Yeah, it worked. Let's try to submit this code. Yeah, it got succeeded. So this is how you find the sum of nodes with even value grandparent. So this is not that hard. Like you have seen, this is like a normal recursive solution. So this is how you find. So please make sure you like, subscribe. Thank you.